So we will go ahead then and start with IBM and David Ferrucci. David Ferrucci is a research staff member and leader of the Semantic Analysis and Integration Department at IBM's T.J. Watson Research Center. In 2007, he began exploring the feasibility of designing a computer system that can rival human champions at the game of Jeopardy, and as we all know, he succeeded, and the IBM Deep QA system won. And to interact with David and to talk to him about his experiences, we have a panel here of CSU faculty and students, and I'll turn it over to Professor Bruce Draper from the Computer Science Department.
Well, thank you, H.J., and nice to electronically meet you, David. Can you hear me?
Yes, I can. Nice to meet you.
First, I'd like to introduce to my right is Steve O'Hara, one of the graduate students in the Department of Computer Science. And to my left is Jason Llewellyn, who's one of our undergraduates.
How you doing?
So we thought it'd be interesting to talk to you and ask you some questions about your experience with, obviously with Watson and the whole Jeopardy experience. Starting off with really, how has the public reaction been? After the initial reaction of cool, do people really, has this sustained people's interest? Are they scared? Are they excited? How have people largely reacted to us?
Well, in the beginning, as we started talking about it to the general public, the audience was almost bipolar in their appreciation and reaction to this. On one end of the spectrum, you had folks who thought, what's the big deal? Don't computers know everything? Why wouldn't it, know all the answers to these questions? And on the other end of the spectrum are people who thought, oh my goodness, Skynet, Watson's going to take over the world and eat our children. So there were these, these two bipolar extremes. And I thought, as a person who's been in AI, largely my whole life, I've been fascinated by it since I was in high school. It was interesting to think about how opaque people's understandings were about, how computers work on the inside. And in fact, one time I was interviewed by a radio show host, and they started off by saying, this was before the game was played, and the host said, so let me understand this. You put all the questions into the computer, you put all the answers in, and then when the clue shows up, Watson speaks the answer, right? I was like, no, we don't know what the answers, we don't even know what the questions are going to be, never mind the answers. And the radio show host said, well, then how do you do it? And I said, exactly. That's exactly the issue. So, I think that it's usually, there's this huge variety in people's reaction to this. And when you dig into their model of how computers work, the model is almost table-driven. In other words, you put all this information in a table, and the computer kind of just looks it up. And then when you start to explain that, it really has to start to analyze that information. People don't know exactly what's involved in that. So then they go to the opposite extreme, which is you have some sort of human intelligence. And they project that kind of human intelligence onto the computer. And that's not really what's going on either.
So you mentioned you've been in AI almost your whole life. What is it you did before Watson? How did it sort of lead you to Watson?
So right before Watson, I worked here at IBM developing something called UIMA, or the Unstructured Information Management Architecture, and that's actually now an open source project. You can find it under Apache, the Apache open source site. And that architecture is designed to allow people to build applications that integrate diverse collections of text, image, and speech analysis. So the underlying hypothesis of why we need an architecture like that is because intelligent systems, intelligent architectures, applications that behave intelligently over data are going to require lots of different independent analytics that have to be integrated in complex systems. And UIMA is at the substrate, if you will, the plumbing for enabling that. And in fact, Deep QA is built on top of UIMA. So Watson is built on that UIMA infrastructure, if you will. But as an AI scientist, and the reason I got into that, the reason I was excited about that was because there was this underlying belief that complex systems were going to require complex engineering, and you need to layer these systems. So the 5 years before that, we kind of developed that infrastructure for building things like Watson on top of. But as an AI scientist, I was very much into what was traditionally thought of as the logicist approach to AI. So in other words, if you want to solve a problem in AI, you model it, you build an ontology, you define all the concepts and the relationships between the concepts, all the properties that the concepts have, and then you think about how you want to infer things. In other words, if you populated that knowledge base, how would you now write rules, or how would you infer new conclusions from the initial information through applying logical operators? What I learned fairly after doing this and indulging myself in this for years, because that's really the way I look at it now, is almost luxuriating in what I liked to do with my brain, which was to build logical models, to look at the world and say, oh, there are different kinds of things, there are these various kinds of structures. I can think of most generally there's things, and then there's people, and then there's physical things and abstract things, and you build this big model. The problem was that it's endless, and what you realize very quickly is extremely brittle. It's very prejudiced, because what you're capturing is one view of the world, and that structure is very brittle. Because when people now want to reason and infer over that, they're completely locked into that model. And it's very hard to query that model if they don't understand it. So it becomes a very brittle and individualistic kind of view of the world, where a bunch of assumptions are tied up into that. So to build intelligent systems, you had to get around that, my view was, and many others. You had to be able to process knowledge as it naturally occurred in the world, as humans created it and communicated with each other. So naturally occurring knowledge, things like text, speech, and images. How do you analyze that and extract knowledge out of that?
So you've mentioned images a couple times. Were there any video daily doubles or video questions in the last?
There were not. We did not include image analysis into Watson, nor did we include actually speech. But, and this is because we really want, in this particular challenge, we wanted to focus on the natural language processing stuff, the text processing stuff. And Jeopardy was okay with that because they had made allowances for blind contestants, people reading Braille, and things that didn't have images and stuff like that. So that was compatible with their view of the game. We wanted to limit it to the natural language aspects of it. But the vision for intelligent systems is really to include multiple modalities, and to include speech analysis and to include image analysis. And in fact, UEMA, again, the underlying infrastructure that enables you to build applications like this, admits image and speech and text analytics into applications.
So you're working on UEMA. What inspired you to go for Jeopardy? And how did you convince the hierarchy above you to support that?
Great question. So while I was working on UEMA, which is very much about engineering and infrastructure, I also had a team working on question answering, and my heart, my personal interest was in advancing AI. So while the engineering was almost a necessary evil, plumbing is kind of this necessary evil, the real interest was in making algorithms that are smart enough to do interesting things. So I had a team doing question answering, or what's often referred to as open domain question answering. In other words, you don't know what the questions are going to be, and you have to produce precise answers. And they had been working on that for some time. That's kind of where my passion was, what I really wanted to pursue more aggressively. But these research projects are typically small. They're like university size. I have 4 or 5 people working on it, explored a bunch of different ideas. One of the most state-of-the-art systems out there. We were competing in these international evaluations and doing quite well. But nonetheless, when the opportunity to take Jeopardy came, there was a lot of fear, a lot of concern. A lot of the researchers were like, this can't be done. There was a lot of movement within senior technical people at IBM saying that this is pure folly. You're not going to get there. You're going to fall on your face. You're going to affect the IBM brand. You're going to lose credibility as an individual. Team members were concerned about that as well. But my attitude was very aggressive with regard to this. I sat down with my team and said, I don't want to spend the next 5 years churning out, journal papers. I really want to push the limits and know whether or not, if we made the right investments in this technology, if we could do something like this. Our expectation working in open domain question answering, our expectation of working in AI, our expectation for building UEMA, were all based on the premise that we can do something like this. So I said to them, I'd rather spend the next 5 years learning where all our expectations fail than not trying this at all. Of course I want to win, of course I want to succeed, I do believe it can be done, but even if it can't be done, I want to learn where and how it fails. And it just felt like that was a more legitimate and more aggressive scientific stance than being satisfied with another iteration on conference publications, another iteration on the algorithmic tweaks that we were making each year. Wanted to try something big. So eventually I got the team excited about it and willing to make that class of commitment. In fact, one of the things I said was, we're not even going to look to publishing over the next 3 to 4 years. It's going to be all about pushing ourselves to meet this grand challenge. And if we meet it, more than 3 people will read our publications. If we don't get there, maybe even then people will say, you guys had the guts to do it, why didn't it work? Right? You made the biggest kind of investment in this kind of thing. I argued they're even going to be interested in why it failed. So I tried to turn it into what I legitimately believed was, if we did it right, if we made the right investment, it would all be upside. On the senior management, so that was kind of my team. If you look above me in upper management, there's a very different kind of story there. There was some bipolar reaction to that. There were senior technical people who said, not worth the risk. And there were executives who said, we need to really do something like this. We need to take this risk. We want the next Deep Blue. We want to excite the public about what IBM is doing in research, and that we're committed to advancing the science. So we need something like this. And you had that kind of split. And the way I approached that was, I said, look, let me do a feasibility study. Let me get as much numbers as I can. Let me try to quantify what I think the risk is, or what I think can be done. And they invested in sort of a 6-month, ended up being a 4 or 5 month feasibility study. And I came out with a little bit more of a quantitative argument why I believe this can be done. Still very dicey. I won over enough people. To keep the investment going, but not everybody was sold. And then it was really up to the team to make enough progress to continue that investment going and to get IBM to make the commitments.
So, a question basically on what you just said. I was interested in what sort of early prototypes you had to produce before you had the confidence to believe that you could succeed and issue this challenge.
So it wasn't, so the way it went was, it wasn't quite like we developed a prototype that convinced us we would win, or that we would be grand champions. The goal and the commitment around winning the game against grand champions was evolved incrementally. So what we convinced ourselves at first was that there was a chance to not look stupid. In other words, to end the game with positive dollars. That was actually one of our first internal goals. Can we play a game and end with positive dollars? And we figured out, what kind of accuracy and confidence would we need to do that? And our initial prototypes gave us some hope that there was a path. There was a set of technologies that if we were successful in pursuing, we can get to that point where we can end with positive dollars. We were at that point in the project by early 2008. So we had spent more than a full year on it, maybe 12 to 14 months. We said, wow, this is looking kind of exciting. We have an architecture, we have a bunch of technologies in there. we're doing things differently than we did in the last 5 to 7 years we had spent on QA, and those differences seem to me making a difference. So there was positivism around the approach. If somebody had come to us at that point and said, your entire career is hanging on whether or not you could be grand champions, there was just, we would have said, no, that's too scary, right? So we kind of fooled ourselves into believing that it wouldn't all of a sudden turn around on us, which by the way it did. So by early 2009, IBM had made an announcement that we were going to go on television with this. And then all of a sudden, the meetings and the presentations about the progress went from, hey, this looks really cool, to, you're mucking with the IBM brand. You need to win this thing. So it got very, very intense early 2009, where we were a far cry from feeling that we could confidently win. In fact, I'll tell you the punchline. I mean, we went into the game on January 2011, and we did lots of simulations. We did real games against former tournament champion players, and we were modeling human behavior, and we were modeling all kinds of things, and we did tons and tons of simulations. We went into that final game with about a 70% chance of winning. So that was a 30% chance of me losing my job, basically. So, and that, so it was far from a sure thing. It was basically in the low 70s of winning. So it was a nail-biting experience, actually being in the audience, seeing that live game.
So I'm told that we're running a little low on time here, but I wanted to sort of ask you before you go. Most of us thought Watson was really cool. We got to watch it on our TV sets, and we're rooting for you. But now that you've accomplished this, now that you've done this, what's next? What are your plans to go ahead and what do you do next with Watson?
So me personally, I'm looking for that vacation I could take after 5 years at this point. But I think more generally with regard to the technology, what's exciting about it is pushing the limits of this natural language understanding stuff and get it to help us do decision support. And one of the most exciting areas in my view is medicine, but also it's finance and it's tech support. It's areas where there are huge bodies of natural language content, and there's an opportunity for the system to, the simplest way of looking at it is, if I'm pursuing a high value question, like trying to find the right treatment for my particular patient's problem, and there's so many different options, there's so many different pieces of evidence to consider. When I go down and I try to do that search, with let's say keyword search or web-based search, it's actually an enormous process. This isn't about finding the local pizzeria. This is about, really looking for what are the options? What is the evidence that supports that option versus this option? Can you assess it for me? Can you summarize it for me? Can you score it based on symptom data, based on history data? Can you score it based on geographic data, stuff like that? I want the system to do just a lot more work for me in analyzing those options and connecting the dots and connecting me to the evidence that's going to convince me. What you saw on Jeopardy! What you saw in Jeopardy was a particular answer and a confidence. That's not enough when you're talking about high-value questions. What's behind the scenes in Watson is all the pieces of information it used to basically build an argument for why it came up with that 75% probability. And that's what you want to put in front of the decision maker. And you want to be able to tap that from that huge reservoirs of naturally occurring knowledge. Not from curated databases, which take years and years and then they end up being brittle. You want to find that balance between leveraging both those kinds of information. So that's the way I see the technology going, is helping dramatically in decision support in those different areas.
Well, I think that's all the time we have. Thank you very much. It's been fun talking to you today.
Thank you.